When you think about the North Pole, you don't expect it to go anywhere, and you certainly don't expect it to change places with the South Pole. That would just be wrong. Our magnetic compasses would all point the wrong way. We'd need to update our maps. Birds would probably be horribly confused. Yet, what once sounded like science fiction is not only real, but might already be happening again. Scientists have confirmed that Earth's magnetic north is racing towards Siberia at nearly 55 kilometers per year, more than triple its speed a century ago. The invisible magnetic field that shields our planet, the one responsible for deflecting deadly solar radiation, is weakening faster than ever recorded in human history. For centuries, this magnetic shield has acted like an unseen guardian, guiding birds across oceans, keeping satellites safe, and allowing life to flourish beneath its invisible waves. But now, something deep within Earth's core has begun to change, and every instrument on the planet can feel it. What does it mean when the very compass of our world begins to drift? If the numbers are right, then the next magnetic reversal may already be underway right now, beneath our feet. Earth's magnetic field isn't just a scientific curiosity, it's the silent guardian that makes life possible. Without it, every living thing on this planet would be exposed to the raw fury of the sun streams of charged particles, moving at hundreds of kilometers per second, capable of stripping away the atmosphere and mutating the very code of life itself. NASA describes this field as an invisible shield, one that deflects the solar wind before it can shred our atmosphere. It stretches tens of thousands of kilometers into space, forming what scientists call the magnetosphere, a vast, protective cocoon that bends and ripples with every solar storm. Mars once had such a shield, billions of years ago. Its magnetic field collapsed, and in the ages that followed, the planet's atmosphere thinned, its oceans vanished, and its surface turned to frozen dust. Today, it's a silent reminder of what happens when a planet loses its protection. If we could see Earth's magnetic field with the naked eye, it would look like an ocean of radiant light, waves of invisible energy swirling from pole to pole, shimmering as they wrap our planet in a living glow. But that ocean is thinning, year by year. Its strength is fading, and according to recent NASA satellite readings, the first cracks in this invisible armor are already forming high above South America and the Atlantic Ocean. The question now isn't if the shield will fail, but when, and how soon we'll feel it. Deep beneath our feet, nearly 3,000 kilometers down, lies the beating heart of the planet. A core made of iron and nickel, half solid, half molten. Temperatures there soar beyond 6,000 degrees Celsius, as hot as the surface of the sun. In that vast ocean of molten metal, rivers of liquid iron are constantly moving, rising and falling as heat escapes from the planet's center. This motion generates electric currents, and those currents, in turn, create the magnetic field that envelops the world. It's called the geodynamo, but these currents don't flow straight. Because Earth is spinning, the Coriolis effect twists them into spirals, immense coils of molten metal turning endlessly in opposite directions. Each spiral acts like a gigantic spring of energy, and together they align to form the twin poles, north and south. Picture it, the heart of our world, filled with spinning spirals of metal. glowing and roaring like an endless storm of fire beneath the crust. It's a living engine, one that has powered our magnetic field for over 4 billion years. But recent simulations from NASA and new research published on RxIV in 2025 suggest something unsettling when the convection currents near the outer layer of the core begin to weaken. The spirals lose their balance. The magnetic field becomes chaotic, fractured, unstable, and ready to flip. And deep below us, those spirals may already be losing their rhythm. Since the first measurements in 1831, the magnetic North Pole has never stood still. Back then, it rested quietly in the Canadian Arctic, drifting only a few kilometers each year, barely enough to notice. But over the last century, something changed. The pole began to move and then to accelerate. According to NOAA's 2023 World Magnetic Model, the North Magnetic Pole is now racing towards Siberia at an average speed of 41 kilometers per year, while the South Magnetic Pole drifts more slowly, around 9 kilometers per year. That's more than 3 times faster than it moved 100 years ago. At this pace, the pole could travel thousands of kilometers within a single lifetime, a shift large enough to alter flight paths, satellite alignments, and even the accuracy of smartphone compasses. Scientists are unsure why the pole's movement has accelerated so dramatically. Some believe it's linked to the fluid flows within the outer core. The same molten rivers that generate our magnetic field. When those flows shift, the magnetic field lines follow, tugging the pole along like a needle pulled by invisible hands. Animated maps from NOAA reveal this journey clearly. A red dot sliding from the Canadian archipelago, crossing the Arctic Ocean, and curving towards Siberia. Each decade, the path grows steeper, more urgent, as if something deep inside the planet is steering it with purpose. If this trajectory holds, then within a century, our compasses could point not to Canada, but straight into the frozen plains of Siberia. The story of Earth's magnetic reversals is written not in books, but in stone. Every volcano, every ocean floor carries a record of the planet's shifting magnetic heart. When molten rock rises from the mantle and cools, tiny particles of iron within it act like compass needles. As the lava solidifies, these iron grains lock into place, forever pointing in the direction of the magnetic field that existed at that moment in time. Layer by layer, over millions of years, Earth has built a magnetic fossil record, a geological archive showing that our planet's poles have flipped not once or twice, but 183 times in the last 83 million years. En average, a reversal seems to occur every 450,000 years, but the last one, known as the Brunhes-Matuyama reversal, happened about 750,000 years ago. In other words, by the planet's own rhythm, we're overdue. Yet history shows that these reversals don't follow a perfect schedule. Some eras, like the Cretaceous Superchron, stayed magnetically stable for nearly 40 million years, while others flipped repeatedly within just a few million. The Earth's magnetic field, it seems, has a rhythm all its own, unpredictable and alive. Scientists call this geomagnetic chaos a reminder that the core of our planet is not a machine, but a living, restless force. If history moves in cycles, then Earth may already be past its deadline, preparing quietly for the next great flip. Imagine the planet's magnetic shield, the one that guards us from solar radiation. collapsing to just 10% of its normal strength. The invisible barrier that once deflected charged particles would thin until sunlight itself carried traces of cosmic fire. During such times, auroras would no longer be confined to the poles. Curtains of green and red light would ripple across skies as far south as Florida, Madrid, or northern India, a haunting beauty born from chaos. But beneath the spectacle lies danger. With the magnetic field weakened, charged particles from the sun can penetrate deeper into the atmosphere, disrupting satellites, GPS systems, and the electrical grid below. Power surge, blackouts, and radiation storms could ripple through entire continents. In May 2024, NASA satellites detected something extraordinary, a massive solar storm that struck Earth's magnetic field and briefly created two temporary radiation belts around the planet. It was the first time such a phenomenon had been observed in decades, proof that our magnetic cocoon is vibrating, unstable. Meanwhile, the US Geological Survey warns that solar cycle 25, the current 11-year rhythm of the Sun, is approaching its peak in 2025, when solar flares and coronal mass ejections could reach their highest intensity. Scientists call this overlap, a perfect storm, a convergence of solar aggression and magnetic weakness. When the sky itself becomes electric, even the systems we depend on to measure it can fail. If the Sun's peak collides with Earth's weakest moment, it will unleash an energy storm unlike anything humanity has ever seen. About 41,000 years ago, something strange happened to Earth's magnetic field. For reasons still debated, its strength plummeted down to just 10% of normal for nearly 800 years. The planet stood exposed to the full force of solar and cosmic radiation. Scientists call this episode the Lachamp event. During this time, auroras may have stretched to the equator, skies glowed with strange lights, and radiation levels at the surface increased dramatically. It wasn't just a light show, it was a planetary stress test. In 2021, researchers from the University of New South Wales uncovered startling evidence linking the Lachamp event to a wave of mass extinctions across prehistoric Australia. Massive species, giant kangaroos, wombats the size of cars, vanished in the centuries following the collapse of the magnetic field. Their study revealed a sudden spike in carbon-14 levels trapped in ancient tree rings, a fingerprint of intense cosmic radiation entering the atmosphere. When Earth's magnetic shield weakens, ionizing particles flood the air, altering carbon isotopes and triggering rapid climate swings. Some scientists believe these atmospheric shifts may have changed global weather patterns, disrupting ecosystems and driving the extinction of species already living on the edge. Whether or not it caused those extinctions, the Lachamp event stands as proof that when Earth's magnetic field collapses, the consequences can reach far beyond physics into the realm of life itself. And when it happens again, in a world powered by electricity, GPS, and the internet, the fallout won't just claim giant beasts. It could rewrite civilization itself. There is one region on Earth where our planet's magnetic shield falters a stretch of sky above South America and the South Atlantic Ocean, where the field is alarmingly weak. Scientists call it the South Atlantic Anomaly, or SAA. In this zone, the protective magnetic field dips closer to Earth's surface, allowing higher levels of radiation to penetrate the upper atmosphere. Satellites passing through this region often experience data glitches, sensor resets, and even hardware damage. According to NOAA's 2023 report, the anomaly is deepening by about 25 nanoteslas each year and drifting westward at nearly 20 kilometers annually. Even the Hubble Space Telescope must shut down its most sensitive instruments every time it crosses this invisible danger zone. To monitor the SAA, NASA and ESA are deploying satellite missions like SWARM and the ionospheric probe, tracking subtle changes in the magnetic field's intensity and direction. Their goal to determine whether this anomaly is a local magnetic disturbance or the seed of a future global reversal. Some scientists suspect that the SAA marks the beginning of a magnetic breakup, a place where the orderly pattern of Earth's field has started to unravel. If the South Atlantic Anomaly keeps spreading, it could become ground zero, the very spot where Earth's magnetic shield begins to flip. Earth's magnetic field has flipped before, and it will flip again, but not overnight. Scientists estimate that a full reversal can take anywhere from 1,000 to 10,000 years. A slow, drawn-out process that humanity could adapt to if it began today. Even during its weakest moments, Earth would not become defenseless. Our atmosphere still blocks most radiation. And with foresight and technology, we can shield satellites, harden power grids, and rebuild our systems to withstand the storm. But new research from NASA in 2025 suggests something far deeper, a connection between the fluctuations of Earth's magnetic field and the oxygen levels in our atmosphere over the past 540 million years. When the magnetic field wanes, oxygen tends to drop, hinting that the pulse of life itself may beat in rhythm with the planet's molten core. Perhaps magnetic reversals are not just planetary resets, but acts of renewal, the planet's way of balancing energy between its fiery heart and its fragile skin of life. It's not the end of the world, it's the beginning of a new one, reshaped by the same forces that have guided Earth since its birth. In the next episode, we'll follow NASA's latest data to uncover which regions of Earth are losing their shield the fastest, and whether the coming solar storms could trigger the next global flip.